So now we can move on from these recorded presentations to a live Zoom session with the different teams. We've also asked the judges to be logged into the Zoom meeting, and all the microphones in this room are connected to the Zoom meeting. So if you can step up to these microphones and ask questions, teams will be able to answer them. So can we switch to the Zoom session, please?
Nobody has their cameras on.
So can we see the participants here on the?
None of them have their camera turned on.
But they will be able to hear us talking. Is that right? Okay. So does anybody from the audience have any questions about these presentations? Okay, so since the different teams are online, maybe I can start with a couple of questions, and then let's see where the discussion goes. So in this particular challenge, there are many teams using a 3D unit compared to 2D units from the previous SMRA challenges, particularly the first two teams. Can the presenters comment on how or why they chose 3D units compared to 2D units, and what are the advantages and disadvantages in terms of training as well as performance compared to the 2D units? Can either Sishuai Hu or Jong Yun Kim answer the question?
Can you hear me?
Yeah, we can hear you.
I appreciate that question. We use the 3D model since the 3D structure, the aluminum normal visual, and even disease visual should be preserved well. Besides, our experimental results demonstrate the superiority of the 3D model over the 2D model. Therefore, we choose the 3D dimension model to perform this segmentation and diagnosis task. Thank you.
Just a follow-up question. Are there any disadvantages in terms of training time or memory usage that we need to consider when we use a 3D unit compared to 2D?
I think compared to 2D model, since the data set of this challenge is very small, the training time between the two methods is similar.
Okay, thank you. And I think the third team, Yinye, used a polar segmentation model compared to the other teams. Yinye, can you comment on why you chose the polar segmentation model compared to the 3D segmentation model? Okay, I guess they are not online. Okay, so are there any other questions from the audiences?
I have a question to the, are all of these algorithms downloadable and usable by other groups, or?
Yeah, this one, the algorithms are not downloadable, but I think the teams can share them as they see fit. So everybody is welcome to contact those teams.
Okay, yeah.
So, Huijun, I see you're online. Do you want to say something about the challenge and any other questions for all the teams?
Okay, so it seems my video has some problem. I think I have one question for the first presenter. I do see some of the contours is not so smooth. Could you explain why?
Perhaps we use three neural net dimension models to perform this task. As we know, the 3D models can produce smooth structure. So I believe it can be easy due to this reason. Thank you.
Okay, thank you. I think we do have some questions from online audience. Previously, I do hear someone ask, but it seems to be not very loud.
Okay, yeah.
Anyone from?
Yeah, Dr. Prince has a question.
Yes, I have a question. I'm wondering if any of the teams found a role for stratification to ensure good balance between the training and validation groups. For example, you could stratify based on whatever information you might have.
Just to clarify the question, by stratification, do you mean separating the cases between the training and the testing data based on some criteria?
Yeah, I mean, there must be a range of the features of the cases. Some have large amounts of plaque, some have small amounts of plaque. Ideally, you don't want to have all of your large plaques in the training set and all of your small plaques in the validation.
Yeah, that's a very good point. Huijun, do you want to elaborate on how the cases were separated between the training and the testing? Was there some consideration as to plaque or artifacts being equally separated into the training and the testing data sets?
Actually, it's not that equally presented. It's like quite like the data what we have right now. So it's not equally distributed. And for the training and the test set, it's basically randomly selected.
Can I ask again on that issue whether the training sets and the actual challenge sets, were they all from the same manufacturer machine with the same parameters in terms of voxel size and contrast methods, or was there differences between the data sets?
Yeah, all the data sets were from the same scanner with the same protocol. Okay, Yin Guo from the University of Washington has a question.
Thank you for the great presentations and great work. I have two questions. The first one is, I noticed in group 4, I think, MRGA, when they are doing this final stage of classification, they do not use a deep learning model, rather they calculated like some features like wall areas and normalized wall index, and then they just used a logistic regression or support vector machine, if I remember correctly. Can you comment on like using this more traditional approach rather than using deep learning directly to do the classification?
Yeah. Okay. Yes, we use a traditional model. Actually, it is a machine learning model. But we try the deep learning model to classify it, but it doesn't. But it has. But I think it is because we don't choose the best model and we don't have enough time to test it. The final result of the deep learning model didn't performed worse than the machine learning model, so we finally choose the machine learning model. Actually, you can see in the PowerPoint the results page. Actually, the final result of the classifier is not seems worse than other group. Yeah. I think it's because we don't have enough time.
Okay, thank you.
Thank you.
My second question, I forgot which group. I noticed they used a LSTM, like recurrent neural network structure, to do the classification. Can that group elaborate how that works? Because I think it actually makes sense if you basically you can rolling through and travel through the network using a recurrent structure. It may be helpful. Can that group comment on this?
So which is the team that used the LSTM network?
Maybe.
Okay, I guess they are not online, so maybe you can follow up offline with the presenters.
Yeah, thank you.
Okay, any other questions?
Hello, I'm Lucas Gago, one of the competitors, the one from the last presentation. I have one question. I noticed that there was a big gap, like 2 different clusters on the scores. The first 4 teams had much higher scores than the other 6 from the top 10. And I'm not sure why did it happen. In my case, for example, I noticed that in my validation set, I have a higher score than the one I got in the test. And we don't have information about the test yet. Do any of the teams or the organizer have any insight on that?
So I guess, Huijun, you want to take that question?
Yes, actually, we found that it's, we also think this is very extreme, so we check everything. Firstly, because our evaluation is based on quantitative evaluation and Jarrett's evaluation, and which actually 50% for each of these. So for the quantitative evaluation, basically the 6, level 6 team, actually their score is not that high because the slices actually has not been segmented. Is the number of that slices that has not been segmented is a little high. But when they do the driver's evaluation, so we randomly select slices from all the data set for driver to decide. But we found that for that team, all of the slices we selected, randomly selected, are all well segmented, and on those slices, their human evaluation score did actually have a pretty high score. I think that's why.
Thank you.
Did I answer your question?
Yeah, thank you.
Okay, Hui-Jun, do you want to say a few closing words before we close out the session?
I didn't prepare, but thanks for everyone participating this challenge. And there are still a lot of things. There are still Mikai presentations to be done in the near future. And we hope everyone could join the Mikai presentation. We also thank everyone participate in this presentation session and all the questions. Thank you.
Okay, thanks to all the teams for being present online and be able to answer the questions. And my special thanks to the AV team at here who made this hybrid session success. So with that, I will close out this session and hand it over to my co-moderators.
Good morning, everybody.